Okay. My presentation is visible to everyone. Yes, please confirm it. My presentation is visible to everyone.
Yes, sir.
Okay, good.
Yes, sir.
So, good evening once again. So, unit number three, battery energy storage system, and today we are going to discuss uh, green hydrogen vehicle. So in the previous class, we discussed the following topics. So that is a battery pack sensing. So we have to sense the many parameters, but we discussed the current voltage and temperature. Then isolation and thermal control, and then we discussed the numerical of the battery parameters. So is there any confusion, any query from the previous class? Because there is a long break. So I think we miss around like six class. So is there any confusion, any query from the previous class? Otherwise, you can revise this previous class notes and then please let me know. Maybe you can directly send me WhatsApp message. Otherwise, you can discuss in the next class. So today we are going to discuss the introduction to the net zero emission and what is a green hydrogen technology and introduction to the fuel cell. Why I will cover this net zero emission and green hydrogen because that is a totally depend on the fuel cell. So whatever application in the fuel cell that depend on the green hydrogen technology. So that's why I want to discuss about the little bit on the net zero emissions and then green hydrogen technology. And then we will discuss the fuel cell. What is a fuel cell? So net zero emissions, we normally say our technology is a zero carbon footprint. But what is a net zero emission? Net zero emission refer to achieving an overall balance between the greenhouse gas emissions produced and greenhouse gas emission taken out of the atmosphere. Suppose you are producing the 100 kilogram CO2, correct, during the production of the EV, correct. Just 1 minute, just 1 minute. Yeah, okay. So suppose you are designing the electric vehicle and suppose you are producing the 100% 100 kilogram CO2 in the environment, correct? So after the production of the green, after the production of your vehicle, so now you have to put the technology. So you have to reduce the 100 kilogram CO2 from the environment. Then we can say our application, our design, otherwise our product, it will produce the net zero emission. So whatever amount of the CO2 you produce during the design, after the design, we have to remove that 100 kilogram CO2 from the environment. Then we can say our design, otherwise our product is a net zero emission. So how we can achieve this one? So first one is a step one. So know your data. So first you have to find out the how much CO2 will produce from the product. Then you have to manage your demand because we cannot compromise with our product. Suppose you are planning to make the like 50 electric vehicle per day, but because of the CO2 level, you cannot compromise with the product. Okay, so we have to manage our demand, then make the changes. So what type of changes we can make so we can achieve the net zero emission? So think of it like the set of the scale producing the greenhouse gas emission, tips the scales, and we want to get those scale back into the balance. So that is a simple meaning. So whatever amount of the CO2 you will produce, that CO2 we want to remove after the production. That means there is a net zero emissions, and nowadays all the people discussing about the net zero emission because day by day greenhouse effect will increase. So we have to see how we can reduce the CO2 level from the environment. So issue with the battery operated vehicle. So till now we discussed like IC engine, then electric vehicle, there is a battery operated vehicle, and now we are going with a fuel cell, correct? So what is the issue with the battery operated vehicle? So size of the battery. So everybody want like long drive. So suppose you want to drive the long, then there is an issue with the battery size. Charging time of the battery. So nobody want to stop like 2 to 3 hours to charge your vehicle, and not possible to the long drive. So these are the three major disadvantage in the battery operated vehicle. That's why people switch to the hydrogen vehicle. That is a H2 vehicle. And maybe the some of the students seen that hydrogen vehicle in the Nepal, because in the India many vehicles run based on the hydrogen, correct? So hopefully in the Nepal also hydrogen vehicle is available. So any students seen the hydrogen vehicle in the Nepal, in the Kathmandu? Is it available in the hydrogen vehicle?
It's in the lab only, sir.
Oh, that is only lab, correct? Not like
Not in the road, sir.
not in the road, correct? Okay, no issue. So maybe in the near futures, maybe you will see the hydrogen vehicle. Yeah. So introduction to the green hydrogen vehicle. So this terminology, hydrogen, everybody know. Green hydrogen, that is the most important part. So why we can discuss the green hydrogen? Green hydrogen, which is generated by the renewable energy or from the low carbon power. So we have to generate the hydrogen by electrolysis process. And while electrolysis process, we have to give the power supply. And that power supply, suppose we can get from the renewable energy source, then we can say it is a green hydrogen system. Okay. So renewable energy, otherwise renewable electricity generation, and that is a wind energy, thermal, hydro, any. So that is a renewable energy. Getting the electricity to an electrolyzer. So because we have to generate the H2O, and there is a electrolyzer process, because this concept you already studied during the 10th and 11th science and 12th science. So how we can do the hydrogen production. So there is a electrolyzer. So H2O electrolyzer. So finally there is a H2O electrolyzer. So we can say positive and negative anode and cathode. And finally we can take the like hydrogen. After the distribution and storage of hydrogen, maybe we can directly distribute, otherwise maybe we can store the hydrogen and then we can use it. And finally we can say net zero emissions. So whatever hydrogen is produced, that we can use in different application. So maybe the steam, maybe in the industry, yeah, maybe the electric bus, correct? So that hydrogen we can use to generate the electricity, and then we can say this electricity will produce the 0% of the CO2. Then we can say it is a net zero emission. Okay, so this is the flow of the production of the hydrogen, and why we can say it is a green, because for the electrolysis, whatever current is required, that current we can produce by the renewable energy source, and renewable energy source will produce the 0% energy, 0% CO2. That's why we can say it is a green hydrogen. So different type of hydrogens available in the market. So we can say brown hydrogen. Yeah, first one is a brown hydrogen. Second one is a gray hydrogen, then blue hydrogen, and fourth one that is a green hydrogen. So what is the meaning of brown hydrogen? So hydrogen is produced when coal is transformed under the high pressure condition, and result in the carbon dioxide is released back into the air. So suppose while production of the hydrogen, and then you can use the coal, that time coal will produce the CO2 in the environment. Then we can say it is a brown hydrogen. Second one, that is a gray hydrogen. Hydrogen is produced when natural gas is transformed by burning methane, and resulting the carbon dioxide is released. So suppose you are using the natural gas, and that time it is a burning the methane, and the resulting the carbon dioxide is released. Then we can say it is a gray hydrogen. Third one, there is a blue hydrogen. While hydrogen production natural gas, but the output of the carbon dioxide is captured and store. Whatever CO2 will generate, that you can capture and store, and then thereby avoiding the carbon emission. Correct? Then we can say it is a blue hydrogen. And fourth one, there is a green hydrogen. Hydrogen is extracted from the water using the method called electrolysis, because we have a H2O, and H2O is nothing but water. So we can extract from the water through the electrolysis process, and that power by the renewable energy such as the wind, solar, and etc. Then we can say it is a green hydrogen. Okay. So normally we can say it is a brown hydrogen, gray hydrogen, blue hydrogen, and green hydrogen. But nowadays people are thinking about the green hydrogen because that is 100% CO2 free. So you can see the schematic, otherwise percentage wise. So hydrogen is a zero carbon fuel, and it's come under the three basic colors: gray, blue, and green. So carbon intensity, kilogram of the CO2 per kilogram of the hydrogen. So suppose 1 kilogram of CO2, there is a 9 to 12 percentage of kilogram of the hydrogen. Similar for the blue hydrogen. So there is a 1 kilogram of CO2, it will produce the 1 to 4 kilogram. And similar for the green, there is like 1 kilogram of CO2, so there is a 0.06. Correct? So you can see for the green hydrogen, it will produce very, very less CO2. But you can see the gray hydrogen, it will produce the 9 to 12 kilogram CO2 per production of the 1 kilogram. Okay. So that's why people want to use the green hydrogen instead of the gray and blue. Okay. So schematic layout of power by the hydrogen fuel cell electric vehicles. So FC stand on fuel cell electric vehicles. Correct? So there is a renewable energy sources, there is a solar, wind, and etc. DC to DC converter, because the output of the solar panel there is not a constant, so we have to put the DC to DC converters. And then hydrogen electrolysis process, because we want to extract the hydrogen. So from the water we can extract the hydrogen, and then hydrogen storage tank. And then power electronics converter plus battery, because hydrogen is directly not to produce the electricity. So this component, there is a fuel cell plus power electronics plus battery. So three components here. So there is a fuel cell, because fuel cell produce the electricity, then power electronics, then battery, and finally we can say the electric motor, and finally we can say the hydrogen fuel cell electric vehicles. So these are the major components in the hydrogen fuel cell electric vehicles. So schematic layout of the green hydrogen vehicles. So yes, student, if anyone have any confusion, then please let me know. So schematic component, it is the same like the battery operated electric vehicle. Only changes is a fuel cell and the hydrogen tank. So in the IC engine, we have a petrol and diesel tank, but missing is a fuel cell. But in the hydrogen vehicle, we have a hydrogen tank and we have to add the fuel cell plus electric motor. Correct? So only additional component is a fuel cell and the hydrogen tank. Suppose we are saying it is a green hydrogen vehicle. Okay. And output is only water and heat, and water is only drop of the water. It is not like the 1 liter 2 liter water. It is only few drop of the water, and there is only outlet because CO2 is a 0%, so no CO2, only water and the heat. Correct? So that is a outlet, we can say. So working principle of the green hydrogen. So you can see this is the fuel cell. So this component, that is a fuel cell. This component is a fuel cell, so we can say anode, cathode, and membrane. So membrane, it is a part of the fuel cell, and it is a heart of the fuel cell. We can say membrane. Electro engine, so this is the electro engine. Power electronics converter, battery, hydrogen tank, and this overall we can say the fuel cell car. So how it is work? So hydrogen is passed into the fuel cell. So we can pass the hydrogen in the fuel cell along with the air. So air is directly we can pass the air from the environment as shown in figure. So we have to pass only fuel cell, only we have to pass the hydrogen plus air into the membrane. Otherwise we can say the fuel cell. Okay, inside the fuel cell, hydrogen atom is spread into the proton and the electrons. Okay, so this is the fuel cell. So inside the fuel cell, hydrogen atom is split into the two components. So there is a protons and the electrons. The electrons, and especially the steady flow of the electrons, are the electricity used to operate the electric motor, and that drives the vehicle. Okay, so this is the just operation of the your vehicle. Okay, while the fuel cell is producing the electricity, the proton from the hydrogen combine with the oxygen from the air to produce the water. So as I said in the previous slide, output is a only water drop. The only drain that hydrogen electric vehicles produce the water vapor. So there is a no CO2 in the outlet, only water drop. Okay, so this is a general principle, working principle of the green hydrogen vehicle. Step-by-step process. This is a pictorial view of the green hydrogen. So first step, there is a air. So air is coming from the front. So here is also fuel cell. So we can set the fuel cell. Okay. So air is coming from the front with the interaction with the fuel cell, and there is a membrane. So you can see this is the electrolysis process. Then second one, hydrogen stored in the tank to supply to the fuel cells stack. Correct? So there is a hydrogen electrolysis process, and there is a fuel cell stack. Third step, hydrogen and oxygen react inside the fuel cell. So we can say hydrogen plus oxygen, and oxygen is nothing we can take from the air, interact with the fuel cell and generate the electricity and water through the chemical reaction. Fourth step, generated electricity is supplied to the electric motor, because electric motor input is a electric supply. That electric current we can generate from the fuel cell. Fifth one, the motor use the electricity generated to propel the vehicle. Correct? And last one, the only byproduct of the creating the electricity in the fuel cell stack is water. So outlet is only water, and there is only H2O, and there is only a few drop of the H2O. So these are the major four components. So we can say air. So air is free from air, so no need to pay any amount to take the air from the environment. Only we have to work out on the fuel cell. So how we can produce the H2, that is a hydrogen. Okay. So you can see the proton exchange membrane. So normally people use the proton. Just 1 minute. Yeah. So normally people use the proton exchange membrane. So PEM, normally we can say PEM, proton exchange membrane. So schematic layout, otherwise schematic diagram. So you can see the positive and negative, anode and cathode, and this is the electrolyte process. So incoming, there is a fuel in, okay, exit out, electron, there is a flow, and this is the your load, there is an electric current. Okay, so electron is flow from the load coming, and there is a outer. So air is incoming, so interaction with the air and hydrogen, we can generate the electric current. So fuel in is nothing but H2. Air is coming from the environment, and there is a free. And reaction of this is the membrane, there is an electrolyte, anode and cathode. Because of the interaction of the H2 plus air, we can generate the electric current, and that electric current we can pass from the load, and load, that is your motor. Correct? And then we can run our vehicle. And outlet is an unused air, water and heat. So water is not too much, and heat we can again we can convert the heat into the maybe the cooling, or maybe any other application, correct? But ultimately there is a losses. Okay. So detailed mathematical modeling as well as chemical reaction we will discuss in the maybe the next class. So what is a fuel cell? So till now, any confusion, any query for the fuel cell? Any query?
Sir,
Not
one
the fuel
thing.
cell, for the hydrogen vehicle. Yeah.
Sir, one thing.
Yes, yes.
Sir, how can control the reaction within the fuel cell to increase the amount of electricity?
Yeah. So that is the major disadvantage in the fuel cell. Otherwise, we can say the hydrogen vehicle. One thing is a store of the hydrogen. How we can effectively store the hydrogen, because hydrogen is a very dangerous. And second thing is a controlling of the flow of the hydrogen, because continue we have to generate the electricity. So how we can control the flow of the hydrogen, correct? So that is a major challenges as of now for the fuel cell electric vehicle. So exactly I don't know, so how we can able to control the flow of the hydrogen, but still research is going on, and that is only two disadvantage in the fuel cell electric vehicle. First one, that is a storage of the hydrogen, how we can effectively store, so there is a not any dangerous effect in the vehicle. And second one is a flow of the hydrogen, how we can control the flow of the hydrogen. So that are the two major challenges as of now. Because as of now, I don't have any exact answer. So how we can control the flow of the hydrogen? I will work out and then let you know. Yes. Any other query? Okay. Now we come back to our syllabus part. There is a fuel cell. Yes, green hydrogen is also syllabus part, but for the green hydrogen fundamental, again that is a heart is a fuel cell. So fuel cell is an electrochemical device. It is a chemical device that convert chemical energy of the fuel, there is a hydrogen fuel, directly into the electric energy, heat, water without the combustion. That is a fuel cell. Unlike the battery, fuel cell generate the electricity as long as fuel and oxidant are supplied. Correct? So fuel cell is simple components, electrochemical components that convert chemical energy into the electric energy by membrane. So membrane is a heart of the fuel cell. Okay. Fuel cell electric vehicles are type of the electric vehicles that use the hydrogen fuel cell instead of the alongside battery to power the electric motors. Okay. Why fuel cell for electric vehicles? they offer the zero type pipeline, tailpipe emission, high efficiency, fast refueling. So just suppose you want to refuel the hydrogen, it will take only 2 to 3 minutes. It is the same like the CNG, compressed natural gas, correct? Making them suitable for the long range and heavy duty transportation. Okay, so that's why people want to use the hydrogen vehicle. So high efficiency, zero type pipe emission, and fast refueling. Okay, so different type of fuel cells available in the market. So first one, that is a proton exchange membrane. So normally people use the proton exchange membrane. Second one is a phosphoric acid fuel cell, alkaline fuel cell, molten carbonate fuel cell, and solid oxide fuel cell. So these five type of third, fourth, and five. These five types of fuel cells available in the market, but as of now, normally people use the proton exchange membrane. So electrolyte polymer membrane, operating temperature there is a 60 to 80 degrees centigrade. Application automotive portable power. Okay. Phosphoric acid fuel cell, there is a phosphoric acid, there is a electrolyte. Operating temperature 150 to 200 degrees centigrade. Stationary power plant. Alkaline fuel cell, there is a potassium hydroxide 90 to 100 degrees centigrade, and normally used in the NASA application, space application. Okay. Molten carbonate salt is a electrolyte process 600 to 700 degree, large stationary application. And third one, last one, there is the solid oxide, there is a ceramic oxide 700 to 1000 degree, and there is an industrial application. Okay. Yes, so these are the types of the fuel cell which we can use for the different application. For electric vehicle, we can use only proton exchange membrane as of now. Working principle of the proton exchange membrane fuel cell. So there is a PEM, proton exchange membrane fuel cell. So basic operation, there is a H2 hydrogen gas is supplied to the anode. A platinum catalyst spread, there is a H2 into the proton, there is a H plus, and electron, there is a E minus. Okay. So anode reaction, so there is an anode and cathode. Anode reaction, there is a 2H2, 4H, and finally 4E. So this is the equation balance. So there is a 4 H2. So this is a 4 atom of H, hydrogen, and there is an electron, 4 electrons. So there is an anode reaction. Electrons flow through the external circuit, that is creating the electric current to the cathode. Proton pass to the proton exchange membrane. At the cathode, oxygen O2 from the air react with the proton and electrons to form the waters. So finally, cathode action, otherwise the cathode reaction, O2 plus 4H plus 4E. So finally, you will get the 2H2O. So this is your finally water, and that is your outlet. Okay. So overall reaction in the fuel cell, 2H2 plus O2. So finally, we can say 2H2O plus electricity plus heat. So this one is your final overall reaction in the fuel cell. So 2H2, that is your hydrogen, 2 atom, plus oxygen, and finally 2H2O plus electricity plus heat. Is there any confusion for this reaction? There is an anode reaction and cathode reaction. Because this is a chemical equation, maybe you forgot the chemical reaction. So that's why I want to say, if you have any confusion, then please let me know. Because this is an equation balance, we can say hydrogen atom as well as the oxygen atom. And output is like electricity plus heat.
Sir,
Yes.
how only protons can pass through the membrane?
Yeah, that is a part of the electrolysis process, correct? So we can use the different type of membrane. So there is a membrane property. So they cannot pass the like electron, and they cannot pass like both property. So that is a property of the membrane. So that's why I said for the fuel cell, heart is a membrane. So based on this membrane, we can pass the particular proton and particular electrons. Suppose we use the like local membrane, correct? Not like high cost and high efficiency membrane. Then it is a very difficult to pass the proton and electron both separate. Correct. So it is a property of the membrane, and there is a heart of the fuel cell. Got it?
Yes.
Yeah. Otherwise, it is a very difficult to the separation of the proton and electron. It is very difficult. Yes. So key characteristic of the proton exchange fuel cell: operating temperature, there is a 60 to 80 degree. Efficiency 40 to 60. In the IC engine, efficiency is maximum 20 to 23%, but in the fuel cell, otherwise you can say the proton exchange membrane fuel cell efficiency is up to 60. Startup time less than 1 minute. Power density high. Emission only water vapor, so no CO2 emission. Fuel pure hydrogen, needs the purifications. Voltage per cell, there is a 0.6 to 0.7 volt, depend on the loads and the temperature. So normally voltage per cell, there is a 0.6 to 0.7. So this is the same like we can say the battery cell, correct? In the battery cell, we can say nominal voltage, there is a 3.7 volt. But in the fuel cell, voltage per cell, there is a 0.6 to 0.7. It is the same like the semiconductor diode forward voltage. In the diode forward voltage, there is a 0.7 volt, correct? So it is the same like the proton exchange membrane fuel cell. Voltage per cell, there is a 0.6 to 0.7 volt. Okay. So example of the proton exchange membrane fuel cell that is a use in the vehicles. There is a Toyota Mirai, Hyundai Nexo, Honda City fuel cell, hydrogen buses and truck. So normally people use hydrogen train because in the India, hydrogen train already run on the road, correct? On the we can say on the railway track, not the road, railway track from the in the Himachal Pradesh, correct? And in Germany, many vehicles are based on the hydrogen, correct? So we can say that it's a green hydrogen vehicle. Okay, so there is a zero emission. So as of now, you can see the Toyota Mirai, Hyundai, Honda City, Honda Clarity, not the City, Honda Clarity fuel cell, and hydrogen buses and truck. Challenges: hydrogen storage and refueling infrastructure. Okay, high cost, platinum catalyst, durability under the load cycle. As I said, we have to control the hydrogen flow. That is a load cycle. So how we can able to control the hydrogen flow? Efficient hydrogen production. There is a green hydrogen. How quickly we can produce the hydrogen? Correct. That is the most important part. So this is the as of now current challenges and the research focus for the green hydrogen. Otherwise, we can say the blue hydrogen, gray hydrogen. But for the electric vehicle, we can target only the green hydrogen. Okay. Advantages: yes, many advantages. Conventional efficiency is high, easy and simple construction, require very little attention and maintenance. High power to weight ratio. Yes, hydrogen efficiency is very high, so high power to weight ratio. Fuel cell does not make any noise, so we can say the silence application, other silence operation. Less space required, quick operation, and can be installed at the use point. So we can install anywhere. Apart from this advantage, many more advantages are there. So quickly refueling. Okay. Yes, cost is high, but we can compromise with the cost because environment is most important part. Disadvantage: it is a very costly, short service life, low voltage output, proper attention is needed while selection of material, and this type of material is membrane. Suppose you are not select the proper membrane, then it is very difficult to separate the photon and electrons. So this type of disadvantages are there for the fuel cell electric vehicles. How do fuel cell electric vehicles work using the hydrogen? So this is the same thing. So here I explain the in detail. All the electric vehicles, fuel cell electric vehicles, use the electricity to power an electric motor. So here we use the hydrogen to generate the power for the motor. In contrast to other electric vehicle, FCEV produce the electric using the fuel cell. During the vehicle design process, the vehicle manufacturing define the power of the vehicle by size of the electric motor, because we have to decide what is the size of the membrane and what is the size of the fuel cell. So that is a depend on the manufacturer. So what is the weight of the your vehicle, correct? That receive the electric power from the appropriately sized fuel cell and battery combination, correct? So you want to learn the more about the fuel cell, so please go to this link, so you will get the more information. Yeah, the amount of the energy stored on board is determined by size of the hydrogen. Okay, so how much hydrogen we have to store, that depend on the hydrogen fuel cell tank. This is the different from the all electric vehicle, where the amount of the power and energy available are both closely related to battery size. Okay, so you can see the actual picture of the fuel cell vehicle. So this is a fuel cell tank, electric motor, DC to DC converter, thermal cooling, battery, there is an auxiliary battery, so we can give this supply to your entertainment devices, transmission shaft, power electronics converter, otherwise power electronics controller, fuel tank, there is only oxygen, hydrogen, so this is the fuel tank, and there is a battery pack, and this is a fuel pillar, correct? Why battery pack? Because whatever energy we can generate, that is stored in the battery, otherwise you can directly feed to your motor, correct? So normally we can use the small type of battery, so there is a backup power, so whatever energy is generated, that we can store, and then we can give your electric motor. So key component of electric vehicles, there is a hydrogen vehicles, there is battery, there is auxiliary, battery pack, as I said, so whatever generate the power that we can store in the battery pack, DC to DC converters to maintain the constant DC link voltage, electric traction motor, yes, we have to use the motor, fuel cell tank, fuel filler, so we have to filter the hydrogen, fuel tank, power electronics controller, thermal system, and transmission. Any student have any confusion? What is the use of the battery pack, DC-DC converter, electric traction motor, any components? So here total I think 9 to 10 components. First, second, third, fourth, fifth, sixth, seventh, eighth, nine. Yeah, so total 10 components are there in the hydrogen vehicles. So any confusion, any query for any one components, I hope all of you know about the every component: battery, DC-DC converter, and electric traction motor, fuel cell stack, fuel filler. Filler is nothing but your filter part. So you have to filter the fuel, power electric converter, thermal system. There is a cooling, transmission. There is electric motors. Correct. Suppose you have any confusion, any query, then please let me know. Otherwise, I already explained the every component. There is a battery, auxiliary battery, there is electric drive vehicle, low voltage auxiliary battery, provide the electric. Okay, so there is your entertainment devices. Battery pack, there is a high voltage. Yes.
So hydrogen is in liquefied form or gas form?
Semi-gas form, not the pure liquid, not the pure gas. Semi-gas form. So same like the compressed natural gas. So do you know the compressed CNG vehicle?
No, sir.
So in Nepal, CNG vehicle is not available. Only
Maybe.
petrol and diesel vehicle.
Uh, petrol and diesel vehicle.
LPG gas is also used.
LPG
Oh, yes,
is available. LPG is available.
Yes.
yes, sir. Tuk-tuk tempo is there, and they
Mhm.
use LPG gas.
Yeah, so this all gas, there is a compressed CNG, LPG, all are the not the 100% gases. So there is a combination of the semi gases. We can say the semi gases. It is not like 100%. So you can see the little bit that is a chemical liquid form and the gaseous form. So that's why we can say this is semi gases. Correct. So it is the same like the hydrogen here. So hydrogen is not the 100% gas, but it's a semi gas. So that's why we have to use the filter, fuel filter. So we can get the like 100% gas. So for the generation of the electricity, we have to use the 100% pure gas, not the semi gas. Correct? Yeah. DC to DC converter and electric traction motor. Correct. Here I explained the why we have to use this type of converter. I already explained in the first lecture class. Fuel cell stack, assembly of the individual membrane electrons that use the hydrogen and oxygen to produce the electricity. It is the same like the battery pack, correct? We use the battery pack in the battery electric vehicle. Fuel filler, a nozzle from the fuel dispense attached to the recipient on the vehicle to fill the tank. Okay. Fuel filler plus your filter part. Okay. So both are the combined. Fuel tank, yes, hydrogen storage tank. Power electronics controller, we have to control the power. Thermal system, cooling, yes, because ultimately it will generate the heat, so cooling is most important. Transmission, there is your motor, so we have to connect the transmission. So maybe the in-wheel motor, normally in-wheel motor is available for the two-wheeler and three-wheeler. For the four-wheeler, there is a transmission is compulsory, so we can transmit the power. Yeah. So key point from the today's class. So introduction to the net zero emissions and what is a green hydrogen technology and introduction to the fuel cell. Any confusion, any query from the today's class? Any confusion? Net zero, that is a most important part because nowadays people think about the 0% CO2 because temperature is a rapidly change. Okay, that's why people say it is a green hydrogen technology. In the next class, we will be discussing on the operational characteristic of the proton exchange membrane fuel cell for the e-mobility. So we will see the operational characteristic and mathematical modeling of the proton exchange membrane fuel cell. So one by one equation, we will see how much voltage we have to require to generate the separation of the proton and electron, because for the electrolysis process we have to give the power supply, correct, and that power supply we can get from the renewable energy sources. So in the next class we will see the detailed analysis and the characteristic of the proton exchange membrane, correct. Yeah, so these are the few references so which I used to prepare this lecture notes, correct. So 5 to 6 references. So maybe you can use the any books, otherwise the internet. Okay, so that is up to you. So thank you so much for your kind attention. If you have any question, any confusion, then please let me know. Otherwise, we can stop the today's class. Yes. Any confusion, any query? Okay. Okay, then thank you so much. So we will meet in the next class, maybe the tomorrow. Otherwise, so tomorrow all are free.
I think yes, sir.
Okay, so let's see my schedule. So then we can also take the class on the tomorrow, correct? So I will let you know for the
Okay, sir.
tomorrow class, correct? So thank you so much.